Hello Year 11 Mathematics Advanced students. Today we are continuing on with the topic of Introduction to Calculus and we're learning about the chain rule. So the chain rule is a method for differentiating composite functions. It is also called the composite function rule or the function of a function rule. So say we had 2x minus 1, which is a function of x, and 2x minus 1 to the power of all to the power of 7 is a function of 2x minus 1. Then we have a function of a function, and we have a formal and an informal approach to differentiating this. So the chain rule is if a function of y can be written as a composite function where y equals the function of u, x, then we have dy on dx, so the derivative of y with respect to x, over the derivative of y with respect to u times the derivative of u with respect to x. So this looks like our dy on dx equals du on dy on du times du on dx. So let's have a look at some examples. So we're going to do the formal method for this example, which is our dy on dx equals dy on du times du on dx. Oh, that's a bit of a mouthful. So we have if y equals 2x minus 1 all to the power of 7, find y dash, or our derivative in other cases. So what we do is we let u equal our brackets. So we're going to let u equal our 2x minus 1. And then we're going to have therefore y equals u. So we've just replaced our 2x minus 1 with a u to the power of 7. So then we have that therefore we have our dy on our dx equals dy on our du times our du on our dx. So what we have here is that our derivative, what we need to work out is what our derivative of y with respect to u is, and then what our derivative of u with respect to x is, So what we have is over here, our derivative of y with respect to our derivative of u is our y dash. So it's looking at our u to the power of 7. So the derivative of u to the power of 7 is 7u to the power of 6. And then what we need to then look at is work out what our derivative of u is with respect to our derivative of x. So we have, it's basically our u dash, and this is where our u is 2x minus 1. So the derivative of 2x minus 1 is just 2. So then we substitute these in over here. So we have our dy on dx equals our derivative of y with respect to u, which is 7u6, times our derivative of u with respect to x, which is 2. So this then equals 14u to the power of 6. And so we sub in 2x minus 1 for u. So our dy on our dx is equal to 14 bracket 2x minus 1 all to the power of 6. And so that is finding the function of a function, or using the function of a function rule or our chain rule to find the derivative of y equals 2x minus 1 all to the power of 7. Now we're going to look at the informal method. So if y equals 4x squared minus 3 to the power of 5, we want to find y dash, which is our derivative. So the informal method is stated over here, that our power comes down the front and multiplies the bracket. We drop the power by 1 and multiply the derivative of the bracket. So for this one, our informal method, so we have y equals 4x all squared minus 3 all to the power of 5. So let's find our y dash. So our power comes down the front. So that's our 5. And it multiplies the bracket. So it's going to be 5 times our bracket of 4x squared minus 3. So, and multiplies. So that's our, and then we have our bracket, which is here. And then we drop the power by 1 of our bracket. So it'll be 5 minus 1, which is going to be 4, but we'll leave that then. And then the next step is to multiply by the derivative of the bracket. So the derivative of our bracket is, so it would be if we had, say, fx equals our bracket, which is 4x squared minus 3. Our derivative of that is going to be 8x. Okay, so we're going to then multiply it by our 8x that we have just found. And that is our informal method. So then we just need to simplify this. So this will be y dash equals, if we bring our 8x to the front, so it's 5 times 8x, bracket 4x squared minus 3, all to the power of 4. Then we have y dash equals 40x, bracket 4x squared minus 3, all to the power of 4. So you can do these through the informal method or the formal method, and it would give you the same result. So it just depends which way suits you best and which way you understand better. Okay, so it's a good idea to practice both. Now we're just going to have a go at differentiating a couple, 3 more by ourselves, using either the informal or the formal method, and we can sort of change it up depending how we feel. So let's differentiate y equals 3x squared plus 2x minus 1 all to the power of 9. So I'm going to use the formal method for this one. So that is when we have dy on dx equals our dy on our du times our du on our dx. So what we do for this one is we let u equal our bracket, so 3x squared plus 2x minus 1, and we therefore have our y equals u to the power of 9. So therefore our dy on dx equals our dy on du times our du on dx. So if we write our y over here, so our y equals our 3x squared minus our 2x minus, oh sorry, that's what our u equals. Our u now equals that, equals just our bracket. So if we write what that is over here, then we can differentiate that. So find u dash, which is du on dx, which equals u dash. So that would be 6x minus 2. So how we do that is we times our power of 2 down. So 2 times 3 is 6. Drop our power by 1. And then we get rid of our x, and our -1 vanishes. And then for our y now equals u to the power of 9. So our dy on our du, differentiate that, so we're finding y dash in other terms is 9u to the power of 8. So bring our power down and drop our power by 1. So let's substitute that back in over here. So we have dy on dx equals dy on du is this one here. So it's going to be our 9u, 8 times our du on dx, which is our u dash, which is 6x minus 2. So 6x minus 2. So then what we have here is that we need to multiply these together. So we'll have to substitute our u back in. So we have dy on dx equals 9 times our 3x squared plus 2x minus 1 to the power of 8 times our 6x minus 2. And so we can just rewrite that to be dy on dx equals 9 bracket, bring your 6x minus 2 to the front, and then your 3x squared plus 2x minus 1, all to the power of 8. Moving on to b, we have y equals square root of 3 minus x. So we need to first rewrite with powers. So it will be that y equals 3 minus x all to the power of a half. So then we need to let u equal our 3 minus x, and I'm doing the formal method here. So we let it equal 3 minus x. So therefore du on dx equals just -1. And we have our y is equal to u to the power of a half. So therefore our dy on our du is equal to a half u to the power of -1/2. So then what we have is therefore that dy on dx equals dy on du times du on dx. So that is equal to our dy on du is our a half u to the power of -1/2 times our du on dx, which is our -1. So then we have -1/2, and we can sub our u back in, which is 3 minus x to the power of -1/2. So remember what this -1/2 means. It means that it will be 1/2, and because it's a negative indices, so remember that a to the power of -m equals equals 1 on a to the power of m, and that the half, that a to the power of a half equals the square root of a. So then we'll have that it's 1/2 root 3 minus x. And so that is what our dy on dx equals when we differentiate that. Finally, we have c, and I'm going to use the informal method. Went from caps to normal there, but that's okay. So what we first need to do is first rewrite. So it will be y equals 6x plus 1 to the power of -2. So it's a fractional, a negative indice, sorry, not a fractional. So then when we differentiate this, so then y dash will equal, our power comes down. So it's -2 times the bracket, so times 6x plus 1, and then we drop the power by 1, so it's going to be -2 minus 1, and then we multiply by the derivative of the bracket, and our derivative of our bracket, our derivative of 6x plus 1 is just 6, so then y dash will equal -12 bracket 6x plus 1 to the power of -3. And so then what we do is that we'll have our 12 on the top. So it will be y dash equals -12 over our 6x plus 1 cubed, because just a little recap, this 6x plus 1 negative will turn into our a negative m over equals 1 over am, a to the power of m even. So in our case, it's 1 over 6x plus 1 cubed. Okay, and so our negative 12 is our numerator.